What's up, guys? Welcome back. In this video, we're continuing with factoring difference of squares. In the previous video, we were always just using this formula, and if you didn't watch the previous video, highly recommend you watch it before watching this one, as this one's going to be a lot more complex. So starting off with number 1, we got 8x squared minus 50. We got to factor that. First thing you always check with factoring, can you take anything out of all of the expressions? And notice that from both of these expressions, we can take out a 2. So if we take out a 2, we'd be left with 4x squared minus 25. And then notice this here is a difference of squares. Square root of 4x squared is 2x, square root of 25 is 5. So we got 2x minus 5, 2x plus 5. All right, so that is the answer to this question. Now, one thing I want to note is that we could have also added extra variables. So we could have put maybe like an x squared y minus 50y there. And then instead of factoring out a 2, you'd be factoring out a 2y. And you'd be left with this bracket, then you just factor that as a difference of squares. So there could be multiple things there. But the point is, you always check if you can factor anything out first from all of the expressions before either doing decomposition or difference of squares. Right, so moving on to number 2, this is where it starts getting more complex and a little bit more unique, but still not bad. Really, the trick in these types of questions is just recognizing that it is a difference of squares. So first thing you check, can you factor anything out from these two expressions? Well, from 16 and 25, there's nothing you could factor out of those except for 1. And if you could only factor out 1, you don't really do it. Now, if you notice here, this is actually a difference of squares, because we could take the square root of this and we could take the square root of that both smoothly. The square root of 16 bracket x minus 2 squared, if you remember, if you have a squared and b squared and you take the square root of that whole expression, the answer is just ab. You take the square root of that and then you take the square root of that and then you just multiply those together. Right? So an example of that is like the square root of 4x squared, actually like we did in the previous question. Square root of 4x squared, you take the square root of 4, which is 2. You take the square root of x squared, which is just x. So you're pretty much just taking the square root of each of those two terms that are being multiplied together. As long as they're being multiplied, you can't do that if they're being added. So for example, the square root of 4 plus x squared, that doesn't equal 2 plus x. That there is incorrect. You can only apply this if stuff is being multiplied. So notice in this case, both of these expressions, they are being multiplied. So what's the square root of 16? It's 4. What's the square root of x minus 2 squared? Well, the square would go away and we're just left with x minus 2. Right, so the square root of this expression is this expression here, 4 bracket x minus 2. And then the square root of 25 is just 5. So we'd have minus 5. And then in the other bracket, we'd have this same expression, 4 bracket x minus 2 plus 5. All right, so a little bit tougher to see. But basically, if we relate it back to this formula, this whole thing here, it's like a squared minus this 25 is b squared. So we end up with a minus b, and then this here is a plus b. All right, if you want to relate it back to that. So now we have these two brackets, and notice we could simplify. So we could expand this 4 inside the bracket. Let me actually erase this. just so we're not getting confused. So we got 4x minus 8 minus 5. And then this here would be 4x minus 8 plus 5. All right, and then 4x minus 8 minus 5 is minus 13. And then this is 4x minus 8 plus 5 is minus 3. So this here, the final answer, 4x minus 13, 4x minus 3. Now, another way you could have done this is you could have taken this x minus 2 squared and expanded it. You could have FOILed it, expanded the 16 inside that remaining bracket, simplified everything, and then you would have got a quadratic, and then you could just factor the quadratic into this. But I feel like this is a quicker way to do it. Perhaps it's tougher to recognize, but the more questions you do, the more automatic it's going to become. And I'm going to give you tons of examples. Even the next example is very similar to this. Even in the next example, you could expand everything, and you can factor that remaining expression, or you can recognize that this is a difference of squares and just do it this way. And your teacher might expect you to do it this way. They might not allow you to expand. But either way, this is the final answer, 4x minus 13, 4x minus 3. So the first thing you check is, can you factor anything out? Notice these two brackets are not the same expression, so you can't factor those out. What about the 8 and the 50? Well, notice that we can take out a 2 from both of those. So we would be left with 4 bracket x plus 3 squared. Right, if we take out a 2 from the a, we're left with a 4. If we take out a 2 from the 50, we're left with 25. So now we're just left with this bracket, this big bracket to factor. And a couple things you could do. You could expand this all and then factor it, or you can recognize that this is a difference of squares. Right? A little bit tougher again to recognize, but notice that we could take the square root of this pretty smoothly, and we could take the square root of this pretty smoothly, because the square root of 4 is just 2, square root of x plus 3 squared is just x plus 3, square root of 25 is 5, and the square root of y minus 2 squared is just y minus 2. So this here is like a squared minus this whole expression is b squared. So the square root of this whole expression is 2 bracket x plus 3. And then the square root of this expression is 5 bracket y minus 2. So we'd subtract that. And then in the other bracket, we would rewrite that first expression, and we would add the square root of that second expression. All right, so it's like this is a squared minus b squared. This whole thing is a squared, this whole thing is b squared. And now it's like a minus b, a plus b. All right, so a little bit tough to see perhaps, but as you do more questions, it becomes more and more automatic, as I keep mentioning. So from here, what we can do is we can simplify this bracket. You could distribute, so we'd have 2x plus 6 minus 5y plus 10. And then this here, we'd have 2x plus 6 plus 5y minus 10. And then what you want to do is you want to simplify. So 2x, that's the only variable there. We got minus 5y. And then plus 6 plus 10, that gives us plus 16. And then this is 2x plus 5y plus 6 minus 10 gives us minus 4. So that is the final answer for number 3. 2 bracket 2x minus 5y plus 16, 2x plus 5y minus 4. Actually, now that I think about it, this is one of those examples that would be pretty tough to expand and factor into these brackets. So in this case, this method, difference of squares, is the easiest to do. All right, so that was number 3. Told you these questions would be pretty complex, but better to run into them now versus on your test and not know what to do. So number 4, negative 2m squared n squared plus 98. We got to factor that. First thing you check, can you factor anything out? Notice we could take out a 2 from everything. And this is a negative 2, so we're actually going to take out a negative 2 just to make this positive here. And notice that this expression doesn't contain any m or n variables, so we can't take that out, but we can take out a number. So we're taking out a negative 2. If we take out a negative 2 from this, we're just left with m squared n squared. Then positive 98 divided by negative 2 gives us minus 49. And then from here, this here is a difference of squares. We could take the square root of this smoothly, square root of that smoothly. The square root of m squared n squared, let's do this on the side here. That would be like the square root of m squared times the square root of n squared. Remember, we can like almost distribute that radical to both of these if both of these are multiplying, not adding or subtracting, only multiplying. So square root of m squared is m, square root of n squared is n. So we'd have mn minus 7. This would be mn plus 7. So this here ends up being negative 2, mn minus 7. This is mn plus 7. So that there is your final answer. Right? So all different cases for factoring with a difference of squares. Basically, it's all about just recognizing when you can use this formula here, even for more complex questions like 2, 3, and 4.